Algebra 2, complex numbers. Our objective in this lesson is to be able to identify imaginary and complex numbers and to be able to do basic operations like adding, subtracting, and multiplying involving them. Question I want you to be thinking about is, what is an imaginary number and what do I do with it? Okay, well, what are imaginary numbers? They happen because when we do math, we come up with the square root of -1. And if you think about it, you can't have the square root of -1. There is nothing that you can multiply times itself to get a negative number. So you come up with the square root of -1, you can't go anywhere. It is not a real number. There is nothing that will multiply to the square root of -1. However, it shows up. So because of that, we have mathematicians have decided that they need to have something to deal with it and some properties that go with it so we can work with it. And we call it an imaginary number. Remember, all the other numbers are real numbers, but the square root of -1 is an imaginary number. It doesn't really happen. However, without it, we would not have been able to get these wonderful calculators and cell phones and go to the moon and all kinds of things. We had to have a way to use it. So we have an imaginary number. And since we have the square root of -1, we decide, since it is the imaginary number, it has a special name. It is I. It's kind of like a variable I, but it only refers, when you see I, 9 times out of 10, it will refer to the square root of -1. And there's also another property about it, that if you have I squared, which is, of course, squaring the square root of -1. When you square this, like any other thing, if you take if you square a square root, you end up with the number underneath here. So this is going to give me, whoops, let's put the square here too. This is going to give me -1. So I squared equals -1. And that's a really important thing. With these two, knowing that the square root of -1 equals I, and I squared equals -1, we can do a whole lot of things with this imaginary number. And the thing is, remember that what we're learning are usually just little parts of much bigger problems when it comes to real math. So when we come up with these, and when we're working with it now, remember that in somewhere, in some place, what happens is when they've worked with the I's and the imaginary numbers, they eventually cancel out and they go away if you want to have a real system. So we have the complex numbers, and they're just our imaginary numbers, and they just kind of go along for the ride for a little bit. And I mentioned something else. We have something called a complex number. And a complex number is just a number that is part real and part imaginary. And you always put the real part first. So you might have something like, you have a real part plus an imaginary part. And the imaginary part goes last. So that might be something like 3 plus I. Okay, so there's my real part, and here's my imaginary part. Now that you know what an imaginary number is, let's look at how to simplify them. Okay, and while we have this, I want to always keep our little properties here, that the square root of -1 equals I, and that I squared equals -1. When we simplify numbers, we don't want anything to have the square root of negative anything, okay? So what we want to do is get it into the form with I. That is considered a simplified form. Likewise, if we have I squared or anything like it, we want to go ahead and make that into a real number, which is -1. So let's look at what we have here. I have 3 examples, and we'll do each one. Each one's kind of a little bit different. The first one is the square root of -9. we can rewrite this as the square root of 9 times the square root of -1, because 9 times -1 is -9. And when we do that, we know what the square root of 9 is. I'm hoping you all know what the square root of 9 is. That's 3. And we know also that the square root of -1 is I. So I can rewrite that as just 3I. And that is the simplified version of the square root of -9. Now I have something that's already in terms of I. However, it's I to the 5th power. I to the 5th power, just like any other exponent, means that I've got I times I times I times I times I. Well, every time I have 2 i's, it's like having I squared. So here, this is I squared. And this is I squared. And of course, this I just kind of hangs out there on its own. It doesn't do anything. It's still just I. So I to the 5th equals I squared times I. However, we know that I squared is -1. So I can change this once again to -1 times -1 times I. Well, -1 times -1, negative times negative is a positive, is +1. +1 times I is just I. So I to the 5th equals I. Interesting, isn't it? But true. Okay. And the last one, we have a complex number that we are going to simplify. And in this case, we've got -3 plus the square root of -40. Well, -3, it is what it is. It's a real number. You can't do very much with it. So it's going to just kind of hang out for the ride. But I need to do something with this because I can't have a radical with a negative in it. So what I want to do is change that square root of -40 to the square root of 40 times the square root of -1. Okay, because 40 times -1 equals -40. So now when I go to do this, this becomes I, and I have the square root of 40. And I. Now, I need to remember, though, in the square root of 40, I actually have a perfect square factor. I can take this as 4 times 10, and I know what the square root of 4 is. So I'm going to break this down a little bit more and say, okay, well, that is the square root of 4 times the square root of 10, and I still have I over here. Square root of 4 is 2, so I end up with 3 plus 2 square root of 10 I. Now I know what you're thinking. This is supposed to be simplified, and that doesn't look simplified. It looks actually a little bit more complex than we started with. However, if you follow the rules of simplification, which means that I don't have any negative radicals, this is simplified. So that's what I'm trying to do. So here are my answers for that. Ready to try some on your own? Great. Here are some problems that I'd like you to try on your own. This would be a good time to turn off the video or put it on pause, copy down the problems, work them out on your own, and in just a minute, you'll get to see the answers. Here are the answers. They're worked out for you. And if you did not get the same answers as I did, you might want to pause the video here as well and to see if you can figure out what you did wrong, or maybe I did something wrong and you need to let me know. All right, that is simplifying complex numbers. But we still need to learn how to do a few basic operations. The first basic operation is adding and subtracting. Now, just like before, I'm going to keep our little properties up here, that the square root of -1 equals I, and I squared equals -1. We're not going to use that so much here, but we still want to keep that in our mind, okay? Because in this case, this becomes like adding like terms. Nothing new at all. So here's an example of adding. I have 3 plus 5i, that's one complex number, plus 7 plus 4i, which is another complex number. Now, just because we have them grouped in complex numbers doesn't mean that any of the properties that we've learned about adding and subtracting have changed. And that means that we can still, as long as it's all adding, regroup the way we want to. So I'm going to rewrite it as 3 plus 7, because those are like terms, plus 5i plus 4i. I'm trying to make the i's look like italic, just so that they look like they're supposed to. Okay, anyway, here we are. Now that I've regrouped it, I can add what I can add. Okay, so I can add these two together. 3 plus 7 becomes 10, and 5i plus 4i is 9i. And that's all done. That's all I have to do. Nothing really new, it's just have to remember that because we're talking about imaginary numbers and complex numbers, the imaginary part goes at the end. But other than that, it's just really very much like combining like terms. Same thing goes with subtraction. Okay, here is 12 plus 7i, there's one complex number, minus 8 plus 12i, another complex number. Now, this minus in the middle means that it's subtracting this whole number. So the first thing I'm going to do before I do anything else is remember that subtracting is adding the opposite and changing the whole second complex number to its opposite. Go. Subtracting is adding the opposite. Change those to their opposite. Now that I do that, this is really just another addition problem. So I can now say, oh, well, let's regroup. I have my whole real numbers, 12 plus -8, now that this is negative, and I have my imaginary numbers, 7i plus -12i. Now I can just add these together. 12 plus -8 is 4, and 7 plus -12i, or 7i plus -12i is -5i. So I can write that as plus -5i, or I can go ahead and say minus 5i. And there's my answer. You want to try a couple on these on your own? Great. Here we go. Here's two problems. Notice this one has 3 terms, but really it's just the same. Go ahead and pause and try these problems on your own. Did you get these answers? If not, you might want to pause again and see what you did wrong, or once again, what I did wrong. Although I think I got these right. All right, so that's adding and subtracting. I'm hoping you felt like that was really pretty easy. Okay, now we're going to multiply, and that one gets a little bit interesting, because once again, I have our properties here. And these properties really come into play with multiplying, okay? So the first one, notice I have 3 examples, and they're all a little bit different. And this one, I am starting with the radical form. Now you would think that because I can usually break them apart, that I should be able to say -10 times -5. But since these are imaginary numbers, or they involve imaginary numbers, I can't just multiply them. I first have to break them up into their imaginary parts. So I'm going to do that. I'm going to say 10, or the square root of -10 is really just the square root of 10 times the square root of -1. And then over here, I have this times the square root of -5. So I have the square root of 5 times the square root of -1. Okay? Now, just like I did when I was adding, I'm going to regroup these a little bit so that I can multiply the things that I can multiply together. And I can multiply my real parts, and I can multiply my imaginary parts. Okay, and the reason I couldn't multiply here is because it was kind of a mixture of real and imaginary, and you can't do that. So here we go. I have the square root of 10 times the square root of 5. I'm just going to rewrite it that as a regrouping. If you know that it's 50 and want to just write it that way, I'm okay with that. And this is the square root of negative 1 times the square root of negative 1. Okay, so like we said before, here we have the square root of 50. And here we have the square root of negative 1 squared. Or I have I times I, which is also I squared, and we know what that is. Okay, so square root of 50. I'm not done because I have to think, are there any square factors, perfect square factors in 50? Well, yeah, there's 25. So this is really the square root of 25 times the square root of 2 times I squared, because I times I is I squared. I squared is negative 1. And the square root of 25 is 5. So I have 5 times the square root of 2 times negative 1. And here, when I multiply these together, I end up with negative 5 times the square root of 2. Now what I want you to see is I started off with imaginary numbers. I ended up with a real number. And that's the whole point. See, this is why we have to have this in-between part, because sometimes they go away, and they were just there for a little bit, and they were part of the problem, but it's really just part of the working out of the problem. This is a real number. These were imaginary. So, yeah, it's like your dreams come true or something like that. I don't know. Anyway, that's my answer. All right, let's look at the next one. The next one is already in the form of I, as I have 6I, which is an imaginary number, times 3 plus 4I, which is a complex number. Now this one works just like normal multiplying, where we use the distributive property. I'm not, because I've put this as an imaginary number and I'm already saying that, I'm good to go. So in this case, I have 6I times 3, so that's 18I, and 6I times 4I, plus 6 times I times 4I. Well, 6 times 4 is 24, and I times I is I squared. And like we said, we keep saying, I squared is negative 1. So this really becomes 24 times negative 1. I'm going to rewrite it like that, in fact. I have 18I plus 24 times negative 1. Well, 4 times negative 1 is just negative 24. And the thing is when you do these kind of things, notice we kind of get mixed up, because usually the imaginary part goes last. So we need to rearrange this. So now I have negative 24 from this part, came here, and then 8 plus 18I. Now I'm done. So it's really just the distributive property, but we have to take into account that I squared equals negative 1. So let's try it with the other one. Here I have two complex numbers multiplied to each other. I have 2 plus 7I times 3 minus 5I. Okay, well this one, just like before, we use the distributive property, or we use the FOIL process, where we multiply the first two. See, we had to multiply everything over here by everything in there. So we have 2 times 3, which is 6. And then we multiply 2 times negative 5I, which is going to be negative 10I. And then we have 7 times 3, or 7i times 3, which is going to be 21i. And then 7 times negative 5, 7i times negative 5i, which is going to give you negative 35i squared. Well, there we go with that I squared again. So let's first see if we can do some combining of like terms. And I can, because these two both are just I. So we're going to put those together. I'll have 6 minus 10i plus 21i gives us a positive 11i. And I still have this negative 35i squared. But remember, I squared is negative 1. So I'm going to just say times negative 1. Okay? Well, negative 35 times negative 1 is positive 35. And it looks like this. And hopefully you are seeing that you can do another simplification. These are now both real numbers. So I can add them together, and what I end up with at the end is 41 plus 11i. And once again, I've taken, it looks a lot more real than it did when we started. Okay. So now that you have seen how to multiply complex numbers, I want you to go ahead and try a few on your own. Here they are. And once again, and I put our little properties to start with so that you have them to refer to. The square root of negative 1 is I squared is, whoops, I don't know what I wrote there. Let's cross that out. See, I do make mistakes. I squared equals, you're right, negative 1. All right, here's my 3 problems. Pause, work them out, and the answers are here. Now, I worked out the first 2. I didn't really have room to work out the third one, but notice what happened to that. It's just a real number. And we're going to be using this one in our next lesson. But right now, you're ready for one of my very favorite math jokes. And remember, math jokes are usually a little corny. We have pi and I is saying be rational, and pi is saying get real. See you in class.